Jai Hind, dear students. I'm Dr. Preeti and here with our last part of our electricity chapter, that is we are heading towards the numericals of the chapter. So first let us revise the formula that we have seen in the chapter. So we will start the numericals. First one was we have seen that electric current is the charges flowing through a conductor per unit time. Then we have seen potential difference is the work done to carry a unit charge from one place to another. Then we have seen Ohm's law, and according to Ohm's law, potential difference is equals to current into resistance. V is equals to IR. Then we have seen the series and parallel combination, for which we have done the derivation also to derive the formula for equivalent resistance in series and parallel. So for series combination, it's R in series is equals to R1 plus R2 plus R3 and so on, whatever may be the number of resistors. But if all the resistors are having same resistance, then we can also use the formula N into R. Suppose there are 3 resistors each of 5 ohm. So instead of doing 5 plus 5 plus 5, it doesn't make any difference if we just multiply 5 with 3. Okay. Then 1 upon R in parallel is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. That is for parallel combination. One more formula that we have for parallel combination is R upon N. When all the resistors are having the same resistance, then we can easily use the formula R upon N. Then we have seen H is equals to I square RT, means the heat generated in a conductor, or we call the electricity, the electrical energy that is moving on in a conductor, or we can even be saying that the work done in the conductor is equal to H is equals to I square RT. Remember, heat, work, energy, they have the same SI unit because they are all interconvertible. So whatever the question is asking, whether they are asking you about heat or energy or about uh, 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 about the work done, you can use the same formula. Similarly, this formula could also be written as V into Q. How we got that? We have seen that in the previous video. That is also equal to VIT. This also we have seen in the previous video. Then we have seen that power is equals to very important. Power is very important. That is P equals to VI, potential difference multiplied by current. Then we have I square R, that is also equals to I square R. If potential difference is not given, then V is equals to IR. Placing the value, we get I square R. If current is not given, then we can replace current by V upon R, and then we get the formula V square upon R. Then last comes the numericals to find out the electricity bill. So for that numericals, electrical energy consumed is equals to power, that is in kilowatt, into time, that will be in hours. So that we'll be using to calculate the electricity bill of our house. We'll move on to the numericals from the NCERT book. I'll be reading the questions for you. Just sit with your NCERT books open and try to do all the numericals by yourself and check your answers that when you have done it correct or not. Okay. Second thing, if you have doubts in any other numericals apart from the questions that we are discussing right now in the video, you just send me as a text message in the comment section your question, and I'll be glad to help you out. Okay. So just let's start with the first numerical. A piece of wire has a resistance R and it is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of the combination is R dash, then you have to find out the ratio of original resistance upon the new resistance. Okay, so it's question number 1. It's given in the form of MCQ, but you should be able to solve each and every question logically. So it was given that we have a resistor having a resistance R and it was cut into 5 equal parts. And you all know that resistance is directly proportional to the length of the conductor. So when you're dividing it into 5 equal parts, the resistance of each wire will be now R upon 5. That will also be divided in 5 parts. Now you have to find out that when these resistors are connected in parallel, then what will be the resistance of the combination. So we'll see R 1 upon R in parallel, you all know the formula, is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Okay, so we get 1 upon R1. R1 value is R divided by 5. Denominator of a denominator becomes a numerator. So it's R upon 5. That 5 will go as a numerator, plus 5 upon R plus 5 upon R. How many times we have to write that? 5 times, because we are having 5 such wires. Okay. So LCM will be R, and if we add them all, we'll get 25. So the resist 1 upon R in parallel is equals to 25 upon R. Now it's asked to calculate. This parallel should be written according to the question as R dash. Okay. Instead of parallel, we can write R dash, because it was mentioned in the question that the new resistance of this combination is R dash. So just cross multiplying that, because we want to get R upon R dash. So this R goes up, R upon R dash is equals to 25. So it could be 25 ratio 1. You can take a screenshot. So you will be having all the formula at one place along with this question number 1. Okay, I hope you have taken a screenshot. So the correct option is option number D. Second question, we have already done it here. P equals to Vi, P equals to I square R, P equals to V square upon R, but P is not equal to IR square. So option B is the incorrect part. Okay, it's asked which is not the formula for power. So B option IR square, that's not the formula for power. Third one is a very interesting question. Just try to do it by yourself for every question, and then you can check your answers. So the third question says an electric bulb is rated 220 volt and 100 watt. So if the potential difference is 220 volt, then the power consumed by the bulb is 100 watt. And you are asked that if it is operated at 110 volt, if we reduce the potential difference to 110 volt, what will be the power consumed by the bulb? The first thing that comes to your mind is power is very important. So P equals to VI. We can calculate the current drawn by this and use that value of current for the second part of the question and find out the answer. But in that case, you are landing up with the wrong answer. The answer would be coming 50 watt. Why is it so? Why you are landing up with the incorrect answer? Because when you reduce the potential difference, the current doesn't remains the same. You all know that according to Ohm's law, potential difference is directly proportional to the current. The current flowing through the conductor is directly proportional to the applied potential difference. So if you are changing the potential difference, then the current flowing through the circuit would also change. So we can't use I as a constant and use it for the second part of the question. Then what is going to remain constant even if we change the potential difference? The circuit will be remaining the same. The length of the wire, the area of cross section, and hence the resistance of the wire is not going to change when we are changing the potential difference. So instead of using P equals to VI, we will replace this I, and I is equals to V upon R. So we will use the formula V square upon R. Okay. Now we will put the values. P1 is equals to V1 square upon R. R is the same. So V1 is 220. This implies that P1, the value of P1 is given. It's 100 watt is equal to 220, the square of 220 upon R. So by this we can calculate the value of R, and R comes out to be 220 into 220 upon 100. 0 gets cancelled out, so it's 22 into 22 ohm. No need to find out the answer. Just leave it like that only. That will make your calculations very easy. Now the second part of the question, P2 is equals to V2 square upon R, and that is V2 is 110, square of that upon R. R is 22. So we'll just solve it out. 11 2s are 22, 11 10 times is 110, and then becomes our calculations very easy. So it becomes 5 times 5, and so it is 25 watt. So the new power of the bulb when it is operated at 220 and at 110 volt will be 25 watt. You can just take a screenshot if you want, but I hope you are all doing it along with me. Okay, here comes another very interesting question, that is question number 4. Two conducting wires, okay, just wait a minute. Two conducting wires of same material, equal length, equal diameter are first connected in series and then in parallel to the same potential difference. Potential difference is the same. What is the ratio of the heat produced in series and parallel combination? Okay, so we have two resistors and the resistance of each of the wire is taken same and the potential difference is also same. First, they are connected in series. So when they are connected in series, the total resistance of series combination will be R plus R, that is 2R. Then they are connected in parallel. So 1 upon R of parallel is equals to 1 upon R1 plus 1 upon R2. That is equal to R with the LCM 2 upon R. So R in parallel is equals to R by 2. Just reciprocate that. Okay. So we have got the resistance in series and resistance in parallel. And now what we have to find out the ratio of the heat produced in series and parallel combination. So for heat, you remember one formula, H is equals to I square RT. But here when we are connecting them first in series and then in parallel, does the current remains the same in series and parallel? No, it's going to change. We have done one numerical in the previous video to prove this. Then when we are connecting them in series, then the total current flowing to the circuit reduces considerably. And when we are connecting the same resistors in parallel, that the total current flowing to the circuit is very high. So we can't use this formula because I is not the same in series and parallel. Then what is remaining the same? Here in this case is the potential difference. The total potential difference. I'm not talking about individual potential differences which changes in series combination, but the total potential difference in the whole combination is the same because it's said in the question that we are applying the same potential difference. So instead of I, we are going to replace it by V, and I is equals to V upon R. So it's square. So it's square of both into R as it is into T. One of the R gets cancelled out. So we get the formula V square T upon R. Okay. Now using this formula, heat produced in series upon heat produced in parallel, because we have to find out the ratio. So we will use V square into T, that is the same for series and parallel, upon R of series. Okay. Then we'll write it for parallel combination. What is it? V square into T for parallel divided by, so denominator for denominator becomes a numerator, that is R in parallel. I am representing parallel by P and series by S. This both will get cancelled out because they are the same. So R upon R in parallel upon R in series will give you the ratio of heat produced. What is R in parallel? R upon 2. And what is the R in series? That is 2R. R and R gets cancelled out. So ratio comes out to be heat produced in series ratio heat produced in parallel is equals to 1:4. So which of the option is correct? That is C option is the correct answer. You can take a screenshot if you want, but I prefer that you should be doing it in your rough copy or wherever you want. But just do it in your copy instead of taking a screenshot. It would be a better idea to just have a hard copy of that with you. So now we have the next question. How is voltmeter connected in a circuit to measure the potential difference between 2 points? We already know that it's connected in parallel. And because in parallel combination only, the potential difference remains the same. Next one is just something that we have to just do a lot of calculations, but ultimately the answer very easy. The method is very easy. So we come to question number 6. A copper wire has a diameter of 0.5 millimeter. So diameter is getting 0.5 millimeter. We have to ultimately find out the area, and for finding out the area we need the radius. So we'll find out the radius. So radius is equals to 0.5 upon 2. This is in millimeter. To convert into meters, we multiplied by 10 to the power minus 3. Okay, millimeter into meters, we have converted that. Then resistivity is given 1.6 into 10 to the power minus 8. Resistivity is given 1.6 into 10 to the power minus 8 ohm meter. And the length is asked, how much length of the wire is required for getting these answers. And the resistance of the wire is given to be 10 ohm. Okay, so we all know that R is equals to rho L upon A. We have seen that R is equals to O. In this I forgot to write that. I'll just be writing that as well. R is equals to rho L upon A. That the total resistance of the circuit is equal to resistivity multiplied by length upon area. Okay, so we have to first calculate the area, and area you all know it's pi r square. So it's 22 upon 7 into r is 0.5 into 10 to the power minus 3 divided by 2. We have to do the square of that. So we'll just do it once more. So that is the area. Now just putting the values, we'll do the calculations. We are not going to use any calculator. We are going to do it manually only, because in exams also you are going to do it manually. So R is equals to rho L upon A. So to find the length, L is equals to, we'll cross multiply that, R into A upon rho. I hope this much is clear to everyone. Now just put the values. L is equals to, what is the value of R? 10. What is the value of A? 22 upon 7. 0.5 into 0.5 into 10 to the power minus 3. 2 times it will become 10 to the power minus 6. That is how exponents are multiplied. 2 into 2 into that we have written the area. Now we have to write the resistivity. Resistivity is 1.6 into 10 to the power minus 8. We have just put the values. Okay. Now we are going to solve it out. So 2 11 times will give you 22. 2 here 5 times will give you 10. Okay. Then 10 to the power minus 8 is here. If we take it upwards, it will become 10 to the power 8 plus 8. So I'm erasing it off from here. We'll get 10 to the power 8. 10 to the power 8 multiplied by 10 to the power minus 6. It becomes 10 to the power 2. So can I erase it off and write it here as well? So it becomes 10 to the power 2. Okay. Now let's solve it out a bit more. Here multiplication sign could be removed. So we get 5 into 11 into 0.5 multiplied by 0.5 is 25 upon 100. Can we write it like that? Removing the decimal. Into 10 to the power 2 can be written again as 100. And here we have 7 multiplied by 1.6 multiplied by that 100 is also already there. We'll just cut it off. Now we are left with just let's solve it out. 7 multiplied by 1.6, 11.2. It comes out to be 11.2. So we'll just write the values once again. 5 into 25 into 11. 5 into 25, you all know it's 125. So I'm just writing that 125 into 11 upon 11.2. Okay. Now here it's 11 and we have to divide it by 11.2. Now we have to take some approximations. If we divide 11 by 11, the answer comes out to be 1. But if the number is slightly bigger than 11, we can take the answer approximately as 0.9. So We get 125 multiplied by 0.9. Just let's multiply that. 125 times 9. So it comes out to be 112.5 meters. 112.5 meters. You can leave your answer like this only, or you can write 1.12 into 10 to the power 2 meters. Okay, both the ways the answer is correct. Okay, if you want, you can take a screenshot. In question number 7, it is asked to plot a graph, and we need not plot a graph, practice that right now, because I hope you have a lot of practice of plotting a graph in your mathematics. So in this, if this question comes in your exam, it's very easy because you have to just place the values on the graph paper. So that will be there, and the values are given for the potential difference and the current. You have to just put the values and plot a graph, and it will be coming a straight line graph, because VI graph is a straight line graph. Usually graph paper is not provided in science exams, so that's not a very important question. Next, question number 8. When a 12-volt battery, so potential difference is 12-volt battery, is connected across an unknown resistor, there is a current of 2.5 milliampere. 2.5 milliampere, it is equal to 2.5 into 10 to the power minus 3 ampere. Okay, as we convert millimeter into meters, the same way we can convert milliampere into amperes. You have to find out the value of resistance of this resistor. It's very easy. R, you have to find out. You all know that by using Ohm's law. Just write that statement whenever you use Ohm's law. So by using Ohm's law, you know that V is equals to IR. This implies that R is equals to V upon I. So let's calculate I. V is 12 upon I is 2.5. 2.5 could be written as 25 divided by 10. Okay, into 10 to the power minus 3 is there. So when this 10 to the power minus 3 is there, when it will go up as a numerator, it will become 10 to the power 3. So we are raising it off from here. Okay, now it's very easy calculations. 12 into 10 to the power 3 multiplied by 10, it will be 10 to the power 4. That could be written as 10,000. 25 4 times is 100, you all know that. So it comes out to be 4800 ohm. The total resistance of this circuit is 4800 ohm. It was a very simple question, the easiest of all that we have done right now. Okay. Now coming to question number 9. After every question, I'm giving you some time to just take a screenshot if you want. So question number 9. A battery of 9 volt is connected in series with resistors 0.2 ohm, 0.3 ohm, zero point 0.4, 0.5 and 12 ohm respectively. How much current would flow through the resistor? 12 ohm resistor. Okay, so we have a battery, the potential difference is 9 volt, and we have some resistors. We have to find out the total resistance of them in series, because it's given in the question that they are all connected in series, and we know that when we are putting the resistors in series, the total resistance of the circuit is the combined resistors added up together. Okay, now here why we are finding out the total resistance, but we are asked to just find out the current flowing through 12 ohm resistor, because in series combination the total current flowing through the circuit remains the same. So whatever current is flowing through 12 ohm resistance, that is the same current flowing through 0.2 ohm resistor or 0.3 ohm resistor also. Okay, total resistance will affect the total current passing through the circuit. So let's find out the total resistance. It's 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So 0.2 plus 0.3, it makes it 0.5. 0.5 plus 0.5, it becomes 1 ohm. 1 plus 12 is 13, 13.4. So it's a total of 13.4 ohm resistance that we have. Now we have to find out the current. So by using Ohm's law, we know that V is equals to IR. This implies that I is equals to V upon R, and V is 9 divided by 13.4. We have to do it. So we'll roughly just divide it by 13. Instead of dividing it by 13.4, we'll just roughly divide it by 13. That would make our calculations to be easier. So 9 has to be divided by 13. So it's 0 point. We get a 0 here. On 6 times or 7 times. 7 times it will be 91. Okay. If it is 6 times, if we divide 9 by 13, then the answer comes out to be 0.6. Okay. And okay. So it's somewhere the current flowing through the circuit comes out to be 0.8, then it's come out to be 222, then a 0, then it comes out to be 9 times, I think. 9, 3, 7, 2, 9, 9, 10, 11. Yeah. No, it can't be. Sorry. It's 12. It's coming out to be 0.69 ampere current that is passing through the circuit, or you can write it as 0.7 ampere. Okay, either you can leave it as 0.69 ampere current that is passing through the circuit, or 0.7 ampere. Okay, so for the calculation purpose, we have just taken they just divided it by 13 instead of 13.4 to make our calculations easier. That much approximations are just okay in your final exams as well, because you are aware you are doing it without using any calculator. Okay, I think now we should end up with this video. The remaining questions starting from 10th to 17th we will be doing in the next video, so that one video is not very lengthy for you all to observe. Okay, so that's all in this video. Keep practicing your numericals and work hard to get a very good score in your board exams. Good luck everyone.